Hi everyone, sorry for my absence, but I'm back now and I want to start talking about the Java collection framework, which is basically a set of reusable data structures. Java has built-in data structures like linked lists, trees, maps, sets. There's also something called array lists. So we have a lot of these, and I'm not going to go too much into detail about each one of these because that becomes a course on data structures itself. So I'm just going to try and relate this to object-oriented programming and also talk about a few Java functionality. So first things first, for those of you who don't know what a linked list is, I'll just give you a brief idea. A linked list looks something like this. This is a node of a linked list. It has two parts. The first one contains the data. The second one contains a link to the next node. So a linked list would look something like this, and it would keep going on. And let's say I want to end my linked list here. So all I have to do is say that this thing points to null, and linked list has operations which actually end up being quite simple. So let's say I want to add something between this 1 and 2. I want to add a 1.5 here. So I just create a node with 1.5. I remove this link, and I link this here, I link this here, and that's an addition done. So similarly, remove also becomes quite simple. And if you create a linked list in Java, it actually handles these operations for you. You can just say linked list.add or linked list.remove, and it has all sorts of functions. It has add first, add last, remove first, remove last, and adding it, removing at some given index. So it has a lot of those. Um, Also, let's just quickly see how we would make a linked list of our own if we wanted to. So this is the node class. So it would actually be quite simple. The node class would be something like uh, this. Sorry about that. It would have an object O, let's say, which is this number right here, the 1, 2, 3, and so on. And it would also have a node next. So this is actually a bit confusing for some people because a node class contains an instance of a node class. So but that is actually possible, and the reason why we do it like this here is because Java always uses references. If you were doing object oriented programming in something like C++, you would use pointers. So in that case, it would be something like node start next. So this is the node class, and let's see how we would go about doing the linked list class. So this is the linked list class, linked list, and within this we would actually just need a node head. Sorry about the handwriting. So we can actually implement a linked list with just this much. We would have just a node head, and that would contain this first node, the one, and we can iterate through the linked list using this. But there are some issues with this kind of implementation. The first one is, let's say we want to get the size of the linked list. uh, that would uh, that would have linear time complexity. I hope you know a little bit about time complexities. I'm going to be talking a bit about those here. So, linear time complexity means that I would have to actually go to every element, then go to the next one using the address stored in the element. So, that way, calculating the size would actually mean that I have to go from the first node to the last node and increment a counter every time. So, to make this simple, we also add an int size in the linked list. That actually makes this quite simple. So after we've done in size, every time we perform an add operation, we would increment the size. Every time we perform a remove operation, we would decrement the size. And after we have added the size attribute here, getting the size of the linked list becomes just constant time. So that's one thing. Another thing that is actually very useful is maintaining a reference of the last node. So this 3 right here. The reason why this is useful is because let's say I want to add something to the end of the linked list, which is actually an operation that we might frequently require. So adding and removing from the end right now would mean that we have to actually start from the head and then keep going to the next node, to the next node, to the next, and actually reach the last node and then do the addition there. So that's not exactly a very good idea. So what we do here is we keep a node uh, tail as well, which contains the last node of our linked list. So after we've done this, addition and removal, actually insertion and removal at the end also becomes constant time. So that is another thing that's really useful. So that's all I want to talk right now about linked lists, and you would also see a lot of slightly different implementations for linked lists. There are doubly linked lists as well, which actually have nodes like these, um, which contain data, a previous and a next. So the linked list would be something like this. This points to this node, this points to this node back, and considering I have another node 3 here, and that's the end of my linked list. So this points to this node, and this points back to the 2. So this is a doubly linked list, and another thing that you might see is having a dummy head node. So what people sometimes do is they create a dummy head, and this kind of cleans up the code for us, but that's just various ways to do linked list, and it doesn't really help much in the time complexity or anything. It just simplifies the code. So that's it about linked list. And next I want to talk about something called array lists. So array lists um, are very similar to arrays with one difference. The size of arrays is fixed, so these are actually called static data structures, whereas the size of an array list is dynamic, which means that it can change. So we can keep adding to an array list as much as we want. The way this is actually implemented is, let's say I first have an array list with 5 elements. So I have 1, 2, 3, 4, and 5 here. And next I say that I want to add another element. What internally Java does, or actually any language that implements an array list does, is it copies this array list to a location which has more space. And here I've got space for 10 elements now. So the general trend is to double the size every time we need to increase the size. So I'll tell you the reason in a bit, but what happens is these elements are copied, um, and then the sixth element is added. So this makes the size of array list dynamic, and the reason this helps over linked lists sometimes it is because in linked lists getting an element with where I know the index. So let's say I want the third element in a linked list. It'll be difficult for me to get that, as in I'll have to start from the first element, then go to the second, go to the third. So in a really long linked list, getting to, let's say, the 10,000th element would actually mean that I have to start from the beginning and then iterate through to the 10,000th element. In an array list, that's not the case, because an array list is basically just an array. So getting to the ith index is just constant time. So that's the reason it helps over linked lists. And here the reason why this size was actually doubled was because this copying array list from one location to another would mean that it takes linear time for this operation. So we need to somehow compensate for the fact that we are taking linear time for an addition. The way this is compensated for is by uh, doubling the size, because after we've done an operation which took linear time, we can now add n elements. So the average insertion complexity becomes constant time, because we did an operation of O of n, and then we can add n elements now. So that's the advantage of array lists. The disadvantage here is that, let's say I want to add something at some location. So like we added 1.5 there. Let's say I want to add a 1.5 between the 1 and 2. What we would have to do is move all elements to the right. So this would go here, this would go here, and so on. So this would actually, in the worst case, take again order of n time. If I wanted to add at the first, it would mean shifting all n elements, one place to the right. So that's one disadvantage of array lists. Um, Another thing is how you can make array lists or linked lists. So that's actually quite simple. So you do linked list, and you actually have to mention the type as well. So let's say I give string here, um, and let's say I call it L, and it equals new linked list, and the type again, um, again string, and sorry for the typo, but this is linked list. And this is how you make a linked list. This here is called a generic, and we'll talk about generic sometime later. But basically what you need to understand about this right now is that you need to mention the type. So the type is just what kind of data is going to be in here. It could be a string, it could be an integer, it could be something that you have made, some class of your own, it could be vehicle, it could be car, whatever. One thing you must remember here is that this cannot be a primitive data type. So this has to be an object, which means that if you want to use small I int, you'll have to convert each of them to the wrapper class integer, and then do it. And there are actually wrapper classes around every primitive data type, so that's not an issue. And similarly you can make an array list as well. So I think that's it about array lists and linked lists. As to how many methods you should remember of these array lists and linked lists, I would say try to remember as many as possible because these are very frequently used, and the methods are actually pretty intuitive. When we see hash maps, I won't again be going into too much detail, but maps would mostly have something like a put method for an insertion, whereas lists would have something like an add method. So the methods are quite intuitive, and according to me, you should try and remember as many of those as possible. So I think this video has gone pretty long already. I'll stop here, and next time I want to talk about stacks and queues, which we are going to make on our own using these array lists and linked lists. So see you then.